Last week, we learned about the possibility of life existing within the Sun's habitable zone. Although only looking within a star's typical habitable zone is an easy method of elimination when it comes to allocating precious telescope time, this narrow-minded approach is becoming less and less relevant as we discover more about the conditions in the outer solar system. Today, we're going to find out how missions to the outer solar system have changed our perceptions on where life can exist. It's highly unlikely that we'll find life actually on one of the gas giants, due to the fact that they have no real surface for life to live on. However, Jupiter and Saturn are both surrounded by an array of moons, some of which are bigger than our smallest planet. Though most are no more than glorified asteroids, quite a few do have interesting features. Europa is a tidally locked moon of Jupiter and is roughly the same size as our moon, but in my opinion it's a lot more exciting, as it has an icy surface, a thin oxygen atmosphere and a saltwater ocean that could hold up to twice as much as all of the water on Earth's surface. Its surface is crisscrossed with fractures and irregularities, suggesting that its icy surface is being broken apart and renewed as a result of convection in its subsurface ocean. This idea is reinforced by the fact that its surface is relatively young, less than 100 million years old. The reddish cracks are possibly from sulfate compounds that are impurities in the ice, evidence that at least some of the essential compounds needed for life are present. This, along with the fact that it has a hot core and some sort of magnetic field, makes it one of the best possible places for us to find life. Similar to Europa, but much smaller, Enceladus's orbit of Saturn remains elliptical due to the gravitational tug-of-war with Dione, a nearby moon in orbital resonance. This means that Enceladus is stretched to different amounts depending on where in its orbit it is. This squashing and stretching creates tidal heating, which is thought to be the reason that its subsurface ocean is kept molten. What's really cool about Enceladus is that it has jets of water erupting almost constantly from its south pole, which falls back onto its surface as snow, keeping its surface fresh. This is why it is the most reflective body in the solar system. Cassini, which orbited Saturn from 2004 to 2017, flew through these jets to take samples of essentially the inner ocean. These have since been analysed, showing that its ocean is made of nutrient-rich salt water and contains the organic compounds needed for life. This makes Enceladus a prime candidate for life. Titan is the second largest moon in the solar system, one of the two that are bigger than Mercury. What makes it so fascinating is that it's the only moon with a thick atmosphere. Its atmosphere is nitrogen-based, like our own, and has surface features similar to ones on Earth. This is due to its methane cycle, which creates weather and acts like our water cycle, but at minus 180 degrees C. This creates a seasonal system of lakes and rivers that are made of hydrocarbons. Titan may also have cryovolcanos, releasing torrents of ice and ammonia from a subsurface layer of ammonia-rich water. This makes Titan a decent candidate for life, as we already know that it has organic compounds on its surface, and that under its current surface conditions, these could combine to create complex molecules like DNA. One of the biggest obstacles for life here is that liquid water, at least on its surface, is practically non-existent. And as all life on Earth requires water as a solvent or in metabolic reactions, what's safe to say, water is pretty important. It might not be totally prohibitive, as methanogenic organisms have been proven to be hypothetically possible, at least for microbial life. Now it's just a case of finding out whether or not it actually does exist on Titan. There actually is evidence that all of these moons have a subsurface ocean of very salty liquid water. So it is possible that if there's an energy source, like from the interaction between the hot core and the bottom of the ocean creating vents or volcanism, that halophilic organisms technically could exist here. It's just quite unlikely. Triton is the largest unmapped body in the solar system, with only 40% of its surface mapped with data from a Voyager flyby 30 years ago. From the small amount of information that Voyager 2 beamed back, we can tell that Triton, the largest moon of Neptune, has active cryovolcanoes, suggesting that it has an at least semi-liquid subsurface ocean, where, like Callisto, Ganymede and Dione, life technically could exist. Personally, I think it's unlikely, but it's definitely still worth visiting this moon, if only to discover more about our own solar system. Io's chances of hosting life are minute, but it's a really cool moon and I'd like to talk about it. So Io is the closest moon to Jupiter, and this, combined with the gravitational pull of the other Galilean moons, causes it to be under immense tidal forces. This stress means that it's the most geologically active body in the solar system by far, with over 400 active volcanoes, some of which are powerful enough to launch silicate lava and sulfur compounds 500 kilometers above its surface. These plumes can be so big that when scientists analysed the first close-up images of Io, they thought that there was an undiscovered moon hiding behind it. So obviously most of its features are volcanoes, but it also has mountain ranges, with mountains double the height of Mount Everest. Another consequence of its proximity to Jupiter is that it has the least water of any known astronomical body in the solar system. It was probably all boiled away from Jupiter's early heat at the start of the solar system, or from its own volcanism. It also has no atmosphere, as anything that is produced during eruptions is stripped away by Jupiter's magnetic field. All in all, Io is a very uninhabitable place. I can't forget about Pluto. Although no longer considered a planet, and the minor fact that it only receives 1/900th of the light from the sun that we get here on Earth, the Pluto-Charon binary system is still very interesting. Our moon orbits the Earth, with the barycenter, the point they move around, is firmly beneath the Earth's crust. But for Pluto and Charon, they actually move around a point that's just above Pluto's surface. On Earth, the tidal forces from the moon are only strong enough to move water, creating the tides we see twice a day. But in the Pluto-Charon system, the tidal forces are strong enough to create friction within the bodies and heat them up. This means that they probably have a layer of liquid water beneath their surface, which powers cryovolcanism on both of them. There are even more dwarf planets and asteroids as we go further out into the outer solar system, including the possible planet 9. But it's highly unlikely that we'll find life so far from the Sun. Then again, our perspectives regarding which places are habitable broaden every single time we go out into our solar system and find out more about our vast neighbourhood. So, do you think that we'll find life in our solar system, other than on Earth of course? Where would be your #1 place to look for it? Should we even be searching for it? Getting philosophical here. Thank you for watching this series, and ciao for now!